Hello everyone, welcome back to OnPrep. And today's topic for system design interview is URL shortening service. This is one of the widely asked interview question on the system design interview. As I always suggest the 7 step-by-step approach on the system design interview targeting for a role from SD1 to senior software engineers and from staff software engineers to principal software engineers and engineering managers. The difference between these IC roles to lead roles lies on the deep dive. So we will go in depth from each of these steps as we go. So let's start with the functional requirement. First of all, let us understand what is the URL shortening service and where it is used. So when you have a long URL which we wanted to communicate to the customers via email, SMS or any kind of a notification, we would have a very long URL which is going to consume a lot of space while creating the content for SMS or email, and the length of those URL is not the focus of these communication. The content of those notifications are important, and if we can have a shortest URL, shortest possible URL as part of the communication, which user can read the content and click on the URL, that would be the ideal approach for sending any communications to the users. So with that, we understand that creating the shortest possible URL is the requirement of the system. With that, the examples are kind of a bit.ly link on which you will have a URL like bit.ly and then slash with the some unique numbers which can uniquely identify the original URLs. So when the communication is being sent to the users, they can read the content and click on that shortest URL which will redirect to the original URL. So we have two core functional requirements. One is to generate the shortest URL when we pass the long URL, and the second is when we pass the short URL, we should be able to get the long URL. With that, let's get started with our first step on gathering the functional requirement of the system. So our first core requirement is to convert the long URL to short URL, and the second requirement is to convert the short URL to long URL. We can have analytics as well, but we can think about as an extended requirement if we have time. What does analytics means is we wanted to generate some kind of a report for the business or sales teams that how many times the URL is being hit by the users which we have sent to their email or SMS as part of the communication. So to focus on the core functional requirement, I will skip the analytics part so that we can focus more on the generating the short and long URLs. Step 2, non-functional requirement is understanding the quality of the system and scalability and security of the system. Let's start with low latency. In which area we wanted to have a low latency? We want a low latency on search. We want low latency when we wanted to get the long URL from the short URL. It means when user click on the short URL, we should be able to redirect to the original URL as soon as possible. So this is something like a read operation. Talking about the cap theorem, in case if we need to partition the data for some reason, if we need to partition the data, either the entire data cannot fit into a single instance, or we would have thousands of requests per second that a single instance would not be able to serve within the given SLA. So we wanted to prioritize consistency over availability in case of partitioning the data. So let's say we are writing, basically in the write operation, we are generating the short URL from the long URL. In that case, we do not want to compromise with the consistency. So we definitely need to prioritize consistency over availability for the write operation. So in this case, consistency is prioritized over availability for the write operation. It means when we are going and creating the short URL after providing the long URL, we are maintaining the synchronous communication. So first we will hit the APIs to generate the short URL, and that API is gonna uh, store these records in the database and get the response and send back the response as part of the API response to the users. So this is the synchronous communications, and as you can understand, here we are making the consistency between the system. In case if we wanted to get into the asynchronous communications and we wanted to compromise with the consistency and we wanted our system to be pretty fast in this case. So let's say as soon as we get the request from the user to create the short URL, we can just send the response back to the user that your short URL is created successfully. And then in asynchronous communication, we will go into the database, generates and save these records into the tables. And once the record is being created, asynchronously, we can send back the response to the user, let's say after a few milliseconds, that this is your short URL. As a first step, user got the successful confirmation. And in the second step, the customer actually got the URL. So in the first step, user can get the short URL, right, while it is not being saved into the database. And in the second step, in the asynchronous communication, customer get a kind of a confirmation, yes, your short and long URL is being saved into the system. So here we are definitely prioritizing the performance here, but you understand which is a good customer experience. But in case of any failure while saving the record into the database, we might get inconsistency in the system. The user would think that the URL shortest and long URL which user has got the configuration, and user will go ahead and share with their customers, but there are chances that this configuration is not being saved into the system, and at later point of time the mapping between short URL to long URL users does not exist in the system, and user will not be able to redirect it to the original URL from the short URL. So these are the terminologies that you should be able to explain to the interviewer, and from here we can get into the back of the envelope calculations, that how many requests we are getting, what is the size of each of the record, what is the capacity of the storage we need. But that might not be the area which interviewer is expecting you to spend your time and get into those calculations. So get the clarification with the interviewer that interviewer is really looking for you to calculate all those numbers. Also watch my previous videos, one of the example on Book My Show, where I have explained in detail about back of the envelope calculations and the storage capacity you would need to store your data into the system. With that, let's get into the step 3, which is schema design. So what are the attributes data we need in our system? So we need to store the short URL and long URL along with the users who are creating these URLs. Let's start with the entity for shorten. This is a this you can think about as a database table, or the entities JSON responses which you will accept as a request or return as a response of the APIs. So the core attributes for this shorten entity would be the short URL and long URL created at and created by. So we need to have some kind of a mapping here that this is a short URL and this is a long URL for that short URL, and when it is created and who has created, which user has created these URL. So which user is created, so we need the entities for the user table. Which user created, so we must need the entity for the user table. So user will have the user ID, user name, right? So user name, email, phone number, etc, etc. As of now, I can think about these two core entities, and as we go, we can add more entities to our system. With that, let's get into the next step, which is API designing. Looking at the core functional requirement of the system, converting long URL to short URL. So this is basically a write operation when one user is trying to generate the short URL out of the long URL, and that category of the users can send those short URL to their customers. This requirement belongs to that category of the users who are generating the short URLs. By now, you would have also realized the differences between creating the URL and using the URL. So how many users would be generating the URL, writing to the system, in comparison with how many users are using the short URL to browse through or go through the original URL, which is basically a read. So as a high level number, you can think about 1:100 ratio, where one user is creating the short URL out of 100 users, and 100 users are going through the original URLs. So with that, let's start with generating the short URL. So this is basically write operation. So we must have the post API, and the post API format would look like this. This is a API for shortening the URL. Here we can provide the short URL here. So we can have short URL as a query parameter. The response for this API would be the for generating the short URL from the long URL, we must have the post API, and the structure of the post API would look like the API, and we are generating the short URL. We can pass the long URL as query parameter. For generating the short URL from the long URL, we must have the post API, and the structure of the post API would look like this, where we have the API and we are generating the short URL. So we need to pass the long URL here. So the long URL in the request, we can pass the JSON would look like this. So here in the request, we are passing the long URL. This long URL, we can say that this is the original URL, something like this. For example, HTTP and domain name, etc. slash dot dot dot. The response of this API, which would be the short URL. ultimately we need the short URL from here. So here we can have in the JSON of this would be the short URL as the response, and this response can have something like http colon double slash with our domain name shorten URL slash. Now how we wanted to have this short URL, the shortest possible URL, how we generate, right? So let's say for now we have some unique attributes as a query parameter from this API, and we will go through in detail how what are the possible ways to generate this short URL from this long URL. But at a high level, we are trying to understand that what is the input and output of our system. Right now we are in a phase of doing it what we need, right? And as we go, we will get into the step like how we wanted to do it. So from what perspective, we understand that we will need a post API, and the post API, the request and response for the post API would look like this, which would convert the long URL to short URL, and it will send back in the response that this is the short URL for that set of users. Now this URL can be shared uh, to all the different set of users as part of their email or SMS communication, and those users or customers when click on this URL, that will be redirected to the original URL. So now we need another API for those set of customers. So let's say these are the users, the first category of the consumers who are actually creating the short URL, and that belongs to 1 out of 100 ratio. Now for the second set of customers who are clicking on the short URL and getting redirected to the long URL, this is a read operation. So we must need the get API. The structure of the get API would look like the API slash shorten. Here we can pass as a query parameter the short URL, right? In the response of this is basically we are sending back the long URL in this case. Okay, so in this response we are sending the short URL. In this response we are sending the long URL from the past short URL. So here the response would contain the original URL, which is what we have earlier saved into our system. So we need to fetch from our system and send back this response. Also, we need to pass some kind of a status code. So in this API response, yeah, the response would return the original URL. But let's say when the customer click on this short URL in the browser, and if we are just returning this URL, we will just return the URL, right? The customer would be able to see the URL, but we do not want customer to actually get this URL and then again go and copy and paste this into the browser to go through the and visit the original URL. So for that purpose, we have something like status code here. Status code, which is the terminology for the web application. So if we send the status code as 301, so 301 status code give the instruction to the browser from the response that once the browser receives This JSON as part of calling the API, this is an instruction to the browser to redirect the request to this URL. So when customer click on this link, ultimately their request would be redirected to the original URL. So with that, customer need not to get into that level of abstraction that how the short URL and long URL conversions are happening. Customers just know about the short URL and they will be able to browse through the actual URL, which is the core functionality of the system that we wanted to achieve. So at this point of time, we have discussed so far that what is the core functionality of the system and what we wanted to achieve at a very high level. We have not yet discussed about how we wanted to implement the core functionality of the system, uh, which is the main focus area of the interviewer. So the main core focus area, you would have realized by now that how do we convert this short URL to long URL, which is what we wanted to discuss now. You might want to discuss this at much earlier stage with the interviewer, or interviewer might stop you in between and ask you the clarifying questions. How do you wanted to convert this short to long and long to short URL conversion? What are the trade-offs you are making? How interviewer is looking for you, and also about the interviewer, how the interviewer would like you to drive. However, my suggestion here would be start with something simple that you understand, that you know about it, and then slowly get into the deep dive and getting more complexity and how you are proposing the solutions, what trade-off you are making. With that, let's start the discussion, like how are we gonna convert these short to long URL and what are the trade-offs we need to make. So now let's talk about how can we generate the short URL out of this long URL. This long URL could be as long as, could be having the hundreds of the characters with slashes appended to this URL. And then we will have the short URL, shortest possible URL, right? So as short as possible, so that the content would be more focused on the communications which is being sent to the customer and the focus on this URL, and there should not be the focus on this URL. Customer should be able to read the content, right, and then should have an option just to click on this URL. So as short as possible would be as good as. How can we convert these long string into this short string? So this would be our domain name for the short URL. So this would be the fixed length. Now this is the dynamic length of string that we wanted to append to this domain name and return to the customer. So ultimately in our request, once we get this URL, we will extract this part, right? And from this extracted path, we should be able to retrieve this long URL that we should be able to send back as a response of this API. So the conversion of this long URL to this dynamic URL variable is our focus area in this concept. The first approach that we can think about it is generating some kind of a unique IDs and assigning to this URL and saving into our system, so that with that unique ID we would be able to retrieve. So in our system, for every write operation, if we have one unique ID that is saved into our system against the every unique long URL, so that at later point of time when we wanted to read from a system, we should be able to go to that specific unique ID and retrieve the value of this long URL. So you can think about unique ID as a key, and this is a value in some kind of a storage that we are not sure at this point of time, whether it could be a SQL, whether it could be a cache. I know these are the thoughts are coming to your mind at this point of time, but let's go with something simple and in a step-by-step approach. So the unique ID generation is the next problem statement which we wanted to discuss. The first approach, we can think about generating the unique ID number, could be the UUID. Okay. Now, what are the pros and cons of this UUID? But before that, let's understand the overall big picture, how it's gonna work. All right. So this, we somehow, let's say we have generated the UUID for a unique request. For that request, when we are processing the request, right, we had the long URL. So for this specific long URL, we have just generated one unique ID from our system. Okay. And we wanted to assign this unique ID as a key. So let's generate a key for our system, right? So this is a key. The key we wanted to consider to understand in a better way. Let's say the key is this, and for this key, this is the UID that we are replacing with. Okay, so this is a key for our system, and the value here is the long URL what we wanted to convert. So this is the value into our system. This is how we wanted to store the key value into our system after generating the UID from approach 1. Now we have a mapping, right? When we get the post API request for this URL, we process the request, generated the UUID from the system, assigning this UUID with mapping with a value of the original URL. So ultimately, this key will become the short URL for us, and this value is actually a long URL into our system. So for post API, we have saved this information, and when we get a get request where we have the short URL being sent by the customers, we should be able to go with that short URL and retrieve this long URL and send back in the response. So yeah, this satisfied the core functionality of the system for the post API and for the get API. But there is one problem here. This URL, still it is not as short as we wanted, right? This is good enough, but if you see what is the length of this URL, so the UUID length is a 36 character here, 32 hexadecimal numbers, right? Alphanumeric numbers, and 4 are the hyphens. So 32 plus 4, which will become 36. So for any URL which we wanted to generate, this would be at least 36 character long plus the domain name what we have for our service. So you can think about like 36 plus character long URL. That is the one problem what we have. Okay, but that solves many other problem. This URL would be unique across all the system, irrespective of the time, the region, the location. So as we know, the UID which is being generated by the system, it considered many aspects like IP address, MAC address of the system, the region, time, and everything, right? So one way it solves the problem for generating the UUID, one way it solves the problem for generating the unique ID, but it does not give the solution for the shortest possible URL. The second problem with this approach is the size of these attributes. So the UUID takes 128 bits of storage. So if we have like millions and billions of short URL being generated and saved into our storage, do we really wanted to store this much of data for generating a simple unique IDs, right? So as you know, once the data size is increasing, now we might need to partition the data if the data size is increasing, because it might not be able to fit into the single instance of the database. So if we partition the data, again there we will have more complexities, like how do we make this in sync, and how do we retrieve the data when we need. Because of all those complications, we wanted to minimize the size of the data which we are storing into our system. Also, this unique ID consider all the IP addresses, MAC addresses and all that. Do we think about another approach where we can have a simple unique ID generated with a lesser storage, which is our second problem, and also the first problem, which is a major problem, where the length could be shortened as much as possible. With these two problem statement keeping in our mind, we can think about generating a auto incremental number, right? So why can't we just think about just generating the auto incremental number and assigning as a key for the shortening URL and mapping with the long URL. So what should be the length of those auto incremental number? I mean this URL length, right? How much size it would be that could fit to our requirement. Okay, so let's say if we are considering a length of 3 for this as an example, right? So let's say this auto incremental ID has a length of 3, so it can contain 3 numbers, right, at a time. How many combinations are possible if we consider the length of 3 for just with the number? So for each digit, we can have 0 to 9 numbers here. For each digits, we can have 0 to 9 number, then 0 to 9, 0 to 9. So 10 numbers for each digit. So 10 into 10 into 10 would be 1000 numbers we can generate for the auto incremental number. Auto increment number, we can simply use any SQL or any database in-house feature, where when we save this information to the table with the short and long URL, it will automatically generate the ID for that particular column, unique ID, which would be the primary key into that table. That ID we can just append to our domain name and return as a response. So we have got some optimized approach that will shorten the URL. Also, that would take less space to save into our database server. But can we further optimize this? Instead of storing just the number, can we think about storing the characters as well? In fact, the small character and the capital character also we can think about considering as a unique character. So now let's say if we consider ID which contains the number from 0 to 9 plus, and it can also contain the character from A to small z and from capital A to capital Z. So how many combinations we can get and how much should be the size of the data? So here we can have a 10 possible number within that particular digit, here 26 and 26. So that would become 26 plus 26, 52 plus 10, 62. So 62 combinations is possible for every digit. And if we are considering the 3-digit ID, right? So we can have 62 into 3 combinations for 3-digit IDs. With that, let's conclude that if we need an ID with the alphanumeric number, okay, something like this, we will generate A, B, C, 1, 2, 3. If we consider the length of 3 for our shortening service, how much unique IDs are possible to be generated? So this would be for every character we can have a 62, and if we are considering a length of 6, then 62 to the power of 6. If you do the calculation, right, so that would give you somewhere around, I have already calculated this, so that would give you somewhere around 58 billion combinations. Okay, if you wanted to consider the unique IDs for, let's say, next 5 years based on the number of request and response that you might need to discuss as part of back of the envelope calculation, right? So if you just increase this to one more character in the length, so here the possible numbers would be, possible combination would be 10 to the power 62, 62 to the power 7, and that is somewhere around 3.5 trillion records. Okay. So this is to give you your understanding, your trade-offs with the interviewer, that what and how you are thinking. This is not actually for you to come up with the exact number, but to explain and discuss with the interviewer that these are the approaches you are thinking about, considering the core functional requirement of the system and how much data you would be saving into a system, right? So with that, we have concluded that if we go ahead with this approach, right, so the shortest URL which we can generate right from here, this URL, this properties would have like ABC. Let's say we are considering the 4-digit number, right? So the actual URL for this would be something like this for the original URL what we have. So this will be the short URL that users can send to their customers, right? And when customer will click this URL, right, and as we discussed, we can send back the original URL along with the status code of 301. So on clicking of this URL, user will be redirected to this URL. Okay. One point which I forgot to mention, the length, the first problem which we have solved. The second problem, right, what would be the size of these unique ID numbers we should consider, right? Earlier, the UUID size was 128-bit that we were considering. For these IDs, we can consume as a long data type. Long data type takes 64 bits of data. And how many combinations are possible for the long, right? So when we are generating these IDs for 64 bits of data, there would be a possible combinations of thousands of trillions of records being generated uniquely. So we have solved two problems in approach 2. One is the storage part and second is the shortest possible URL generation part. With that, let's get into our next step, which is high level system design. At the high level, we have client which are interacting with our service. This service, they are interacting via the APIs which we have discussed. API, the post API, the post API for shortening. Similarly, the get API for shortening the long and short URL. This service is saving these mapping into the database. Client is making the request to service and service is saving the data through this API to the database. And the schema what we have discussed here are the user and the shorten database table on which these records are being saved. And also there is a unique ID generation part. So here we can have another service which is abstracted how these unique URLs are being generated, right? So unique ID generator, there is one service which is generating the unique IDs. With this unique IDs, this service is doing append on the domain name, saving into this with the mapping of the original URL. And when we get the GET request with the unique IDs, the service can search into the database table and then return the long URL as a response to this client. So this is a very high level uh, on the data flow, how the data flow would work. Now we will get a bit on the deep dive section. Let me create some space for the deep dive. Let me keep it in the bottom here, and let me move this little down here so that I can get space for the problem statement, which we will see now. Okay, so the basic flow would work fine, right? But for the scalable system, right, when we are getting hundreds and thousands of requests, so here let's try to identify the deep dive discussion pointers here, considering the scalability and security in our mind. Okay, so the first area which we can focus is when the URL is already being shortened, right? So we wanted to see if we get the same request again from a different client, do we wanted to duplicate the record into this database server? If not, then before creating it, we can check into the database. Do we already have these URL being generated? If yes, then just return the in the response. If not, then create it. That is one area. Second is when we are getting a thousands, hundreds, thousands, or millions of requests, right, within at the same time, to basically create the URL as well as to read the URL. So you see the read versus write ratio, what we discuss is 1:100, right? So when we are getting the write operation into our DB, we are maintaining the consistency. So probably we might wanted to lock the particular row, or the block the table when we are writing, or in fact we do not want right to the write which is happening where we are basically guaranteeing, right, where we are providing the guarantee to the customer that your write is happened, right? And there we are doing the trade off with the performance of the system. We are taking some time to write into the system and then sending back the response to the user. With the first category of the users, the second category of the users who are doing the read operation, there we wanted to prioritize on the performance of the system, right? So we do not wanted to have the same access pattern for read and write. For that purpose, what we can do is we can have a read and a write replicas for our DB instance. So let me create another instance of this DB and let me call as read replica, and this is a write. So the schema would be the same for both the instance of the server, right? But the difference is just between the read and write, so that this database instance can scale on its own. So at a very hypothetical number, since we are having read as 100 times more as compared to write, so we can have 100 instances of the read databases instances and one instance of the write. So this we are scaling in terms of the cost optimizations and also the optimizations on the performances, queries. These all can be handled separately between these instances. But with that, we get into a second set of problem. How do we keep this read and write in sync? So when we get a request, we can have a eventual consistency or a strong consistency. Strong consistency would mean that when we are writing to this instance, we will be writing into this instance as well, right? If one of these would fail, we will roll back the another instance With that, we are sure either the write happens to all or none. It will take some time for this service to write into the multiple instances. We are providing the guarantee that we are writing to all the instances. So whenever there is a read by a different customer on this instance, they are gonna get the data at that point of time. So this is a strong consistency. If we are going ahead with the eventual consistency, what does that mean is we will not write here directly. We will just write into this instance and we will not write to any more database instances, right? And this replicas in sync we do asynchronously. We could run a kind of a cron job which periodically reads, let's say, every minute and writes to this instance, right? Or we can perform some kind of a trigger as well. Whenever write is happening into this, it will create a trigger and write into these instances. So this is a eventual consistency. What does that mean is, this instance, when some customers are reading directly from this replica, they will get the record eventually at some later point of time. Might not be that specific point of time. They will get the record, they will read from this instance, but eventually. Do we need to always hit our database where we have the millions or billions of record from like last 5 year, 10 year, right? So no. So what we can do is we can introduce the Redis cache here for the read cache, memcache or Redis cache based on your expertise. So here we can introduce a cache. So whenever we get a read for this service, first we can check from the cache, do we already have the shortening of this URL, whether it's a long URL or short URL. The mapping data is already available in the cache. We can return back to the client. If not, then we can go and hit in our database instances to get the matching record. Then we get into the same problem again. If we having a cache miss, if we do not find into the cache, we read from the database, we write back to the cache for some other client for a later stage. Then here also we are taking some time, right, for the request whenever we have a cache miss. Is it a eventual consistency or a strong consistency? So if we are doing as a response, we are writing to the cache, it would be a strong consistency. Let's say we just introduce a layer of any message broker, for example, Kafka here. Okay, so we introduce a Kafka layer in between so that we do not have to write to these systems with a strong consistency, and all these system is eventually written with the use of the Kafka. So same applies to this whenever the writes are happening, we are just writing into the Kafka and we are not actually writing to the database instance. We are just writing to the Kafka and some services consuming the messages from the Kafka and writing back to this readdb and the cache so that it can be used at later stage point of time. I'm not introducing any other service. So let me introduce one more service here, which is, let me call as a sync service. And this is consuming the messages from the Kafka with the eventual consistency and writing back to these instances for the read operations. I hope you are able to understand this. So let me quickly go through it. The request would come for the write. It will generate the unique ID number for that specific long URL. It will save here with the eventual consistency. It will put into the Kafka. One message it will put into the Kafka and just return back the response to the client that this is your short URL. The client would share these short URL to different set of customers. Those customers will make another GET request to this service. Okay, by then this service would have consumed the message from the Kafka and returned to this cache and to this readdb instances. Okay, now that request came from the second set of customer for the short URL, and the customer needs the long URL in the response. So first we will go and check the cache. Yes, we have found that URL, right? If this service has not written by then we can go to these read dbs or write dbs as well, right, as a backup for that. But in case if you have already got the mapping for that long URL, for that short URL to the long URL, we can send back the response to the customer, right? Similarly, if there is a cache miss, we can go to the readdb and pull this information, update eventually to this Kafka, and send back the response to the customer. The third customer comes again. By then, this service would have consumed the message and updated the cache here, so that for the third or fourth customer can get from the cache. So this would consider the multiple scenarios. Here we have considered the scalability part and started with the strong consistency with the high level system design here. But in the deep dive, we wanted to prioritize the performance of the system for the read, for the scalability purpose. So for that reason, from the strong consistency, we went to the eventual consistency. The reason here getting a trade-off with the eventual consistency on read is because if you think about the use cases for the URL shortening service, the URL is creating once, right? And it's okay for that URL to be available after 1, 2 or 3 seconds, right? For hundreds, thousands, millions of customers. It's okay to be available after a few seconds, right? But once it is available, we wanted to prioritize the performance. But whenever we get into the eventual consistency, we also opens up another door for keeping all those replicas in sync. What happens if messages are being missed for 1 minute of time? This Kafka is down. Let's think about it, some network failure or something. For that 1 minute, thousands of write happen in the DB, and these replicas are never in sync, right? Even if these replicas are sync after 5 minutes or 10 minutes, it's okay, right? But let's say this Kafka comes back after some point of time. The newer messages are available by some way. I'm not getting into the complexities, right? But the older message, the time when some network failure happened, those older messages within that 1 minute of time is will never be available, right? So for that we have something called a reconciliation process. So you would have seen in my previous system design discussions as well, I always consider pointing out this problem statement with eventual consistency with the interviewer, and consider introducing the reconciliation as a backup process. This reconciliation process would be a cron job or any services which would run periodically and fetch these records from the primary DB and puts up in the secondary DB, right? It can put up into the secondary DB, or it can write to the Kafka as well. Since it is a backup plan, we can write at multiple places. So ultimately this is gonna overwrite. So it's okay, right, to overwrite multiple times to making sure that the data is always available, even though if it is available after few seconds of time, it's okay. But we wanted to provide a mechanism to have this data available and not missed any data at any point of time. Okay, let's think about any other area of improvement that we can discuss as part of deep dive. Yeah, I can see one more area is when the data size is too large, right? Like after 5 year, 10 year, do we wanted to expire the shortening URL, right? Maybe we wanted to give some expiry date for 30 days, 1 year. And if the data is expired, maybe we wanted to clean up the data, run the cleanup cron job periodically, which clean up the data, right? Also, if you wanted to partition the data, if it will not fit into a single instance of machine, then you can talk about the partitioning the database into a multiple instances. Then you talk about the sharding strategy. But when you have a sharding strategy, you will introduce another problem, right? How do you check with what would be the sharding key with the short URL or the long URL? But this is what the trade-off which you can make, and the and it's not about the right or wrong. It's about what you are thinking and what are the solutions you are proposing, keeping the trade-off in your mind. And if you are proposing a solution, what complexity it will introduce, how you are communicating with the interviewer, and how you are showing your seniority level for giving the decisions, what are the choices you make. So with that, let's get into our last step, which is the engineering excellency of the system. We will not get too much into detail about the engineering excellency, as we have already spent too much time in this video for the core concept and other part of the system. So we will quickly go through it so that it will not remain untouched. So this needs to be discussed at the end of the interview, even if you have a minute to have something added as part of your discussion. So just point out like how you are logging. You would be enabling the logging for your system. You would be looking for monitoring and health check of the system. The areas what we have discussed, if your systems, if some part of the system is down, and creating the alerts if some part of the system is down, so that a developer or a support team can act upon it to avoid any real customer impact. Let me summarize here how we started getting the requirement of the system here. So we started with the getting the functional requirement. We at this point of time, sometime there are some topics which you are new to it, right? So that's my recommendation approach, to start with something simple by making a note of what is the core functionality of the system which interviewer is looking for, and talking about the non-functional part of it that you are thinking for the scalability, performances, and about the consistency and availability of your system. Because why you are discussing at this point of time as a format I suggest is because at later point of time, when you get into the complexities of the system, you might not get chance to speak about it, and this is a time where you would talk about it, so that you do not need to think about it at a later stage point of time. Then you start with something what you know, that what is the data you can see while you are discussing about the problem, and how you wanted to have this data available to the clients or customers to consume, and without thinking about how you would make this data like available, what and how you are doing it, right? This is about what you are doing it. This is not about how you are doing it. Once you are discussed and you get the overview of the problem statement, then you get into like how you will make this data, or how you will do the processing, how you will implement this, considering the trade-offs in back of your mind. Then you will start something very simple to connect the dots of the points what you have discussed so far. Then you get into the deep dive, and there is no yes or no, right or wrong about the suggestions and proposals what you are making. It's about the choices, and what are the trade-offs, and what are the problems and solution you can think about it. And at the end, just touch upon the engineering excellency, which shows your seniority level and how broader you can think about it. What are the ownership skills you have when you take any feature live into the production. I hope you would have learned something today. Please like, subscribe to this channel, and follow me to get more such content related to system design in future. Thank you. Bye bye.